everyone, thanks for watching Lori Wired, and in this video we're going to continue our analysis of our Android banking Trojan, and I think I'm going to take a step back and do a little bit more dynamic analysis of this to see if we can trigger some interesting malicious behavior or maybe get some different dynamic artifacts or files from the malware. So let's open up our emulator and get right into it. I already have my Azure virtual machine for my malware analysis environment up, and I'm just going to make sure that my emulator is in the process of booting up. So I'm going to do ADB devices. Let's see if we can get our device attached. That looks good. And I'm actually going to open up my screen on my host machine. And let's see if we can make sure we're connected on both. One more time, give it a sec to start up. I think that looks good. Let's do our screen copy. And there is our actual emulator screen. So I'm going to be running an ARM64 Android device since that oftentimes bypasses a lot of the different anti-emulation checks. So the malware will go through and see maybe if it has generic in the name or if it has x86, which is a really common processor architecture for Android emulators. So just using an ARM device itself often gets past a lot of these checks, which is kind of interesting. Now my device is up. Let me install my sample. Make sure I've got correct one. Yep, so this is our malware right here. And let's do ADB install banker. And that looks good. Let me check and see if it installed properly. I think this, let me make that bigger, shows me the full name. Oh no, it doesn't. Okay, well, I'm pretty sure that this was the actual icon, this Android G. Let me double check the name in my manifest and see what that was. Let's see what our name was. Yep, this Android G. So that should be our application of interest. So I can go ahead and start it, and I'm going to connect a secondary terminal to this. And let me do. So I have my device and my second terminal, and I'm just going to do ADB shell. It looks like I'm actually not running as root, so let me do ADB root. And that cut my emulator connection, of course. Looks good. Let's redo that and get our screen again. And we still have our application, so that's good. And we can actually connect ADB shell. And now we've got the hash, so we know that we're actually running as root now. And I'm going to do cd/data user 0. And then I'm going to go into our package so we can keep an eye on the directory to see what this application is dropping while it's running and kind of get an idea of what additional files it's going to be dropping to disk, since we're looking for an additional APK that it's going to be loading and maybe potentially other files that might be interesting. Let me double check our name of our package, which was com/bthgoq. So that's going to be our folder name. Which terminal am I in? Yep, there we go. And there it is. Now we just have our cache and our code cache directories, pretty much standard for an application. So let me see if I can trigger this, and let's see what happens. Okay. So it's wanting us to enable our accessibility service for this application. So this GUNC is going to be the name of my application. I think it might specify that in the manifest as well. Let me see if I can find that. How many instances of this do we have? Oh, I missed it. Yep, that looked like it. So that was the full name that we're looking for. Let me close that out, and we'll go back to our emulator. So what we need to do is we need to actually go forward and enable our accessibility services so that we can actually get the full behavior of this application and any potentially malicious behavior. Yes, I'm going to let it run in the background because that is an awesome idea. Just kidding, it's not. So let me see if I can allow that. And then we'll see, allow this to have full control of your device. Definitely, this is a good idea. So oftentimes banking Trojans will try to enable accessibility settings so that they can get the content from the page and potentially manipulate a lot of the different screen content and see if you're parsing passwords or anything like that. So I'm guessing that's what's happening right here. It wants to be able to see what I'm typing in and be able to control that and edit what I'm being able to see from the screen. So I'm gonna do allow. Wait, because an app is obscuring a permission request. Come on, allow. Okay, let me see if I can get this to work. So I think what's happening is because the application has this little toast response that is saying allow accessibility settings, it's actually the system itself is not letting me click allow because it's saying, because this little toast thing is right here, I can't see it. Because I actually physically can't click the deny button. Or maybe I can. No, I'm clicking this a million times and this isn't working. Okay, let me see if I can open up settings themselves. Oh, okay, it's bringing me back to it. That's really funny. I'm actually going to a different page, and no matter what I'm doing, the application is bringing me back to this, so it really wants me to enable these accessibility settings. So let me see if I can go to the actual settings themselves. Oh, this is gonna drive me crazy. Every time I try and change a setting, it brings me back to this page, like, I think every 5 seconds. Okay, apps and notifications, accessibility. Let's see if we can do it this way. It brought me back to the second page before I could click it. Okay, this is my... Wait, now I don't know which page I'm on. Come on. Oh my gosh. It's bringing me back again. This is a problem, Malware, if you prevent people from actually performing the actual capabilities of the malware. That is a problem. So if there's a toast blocking the screen that actually prevents victims from allowing malware authors to manipulate the page and do their malicious behavior, I don't know, that seems kind of like an issue to me. I mean, it's kind of funny though. Okay, can I click this? No, this is impossible. Let me see, is there any way I can get past this? What was the error again? Let me see if I can Google it, if there's a way to turn that off or something. Okay, because an app is obscuring a permission request, let me try Googling that. Okay, it looks like people have searched this before. Let me see if Stack Overflow can help me. Yeah, that's my problem. That's definitely the error message. Go to settings, apps, special access, draw over other apps. Maybe I can reduce that permission. If it will let me get to settings, because it's actually bringing me back every time I'm trying to change this. What was the setting again? It was apps, special access. Oh my goodness. Where is it? I think it's... Oh, every time I try to click this, I don't think this is gonna work. Okay. Let's see if it's in advanced. Okay, display over other apps, I'm getting there. Okay, and that's not an option. Okay, apparently no app is allowed to draw. And then it brings me back here. You know what I think I'm gonna do is I think I'm going to try an older version of Android actually that maybe doesn't have this extra security mechanism, since I'm guessing that this was probably added in a later version of Android to prevent applications from actually blocking people from doing stuff, which makes sense as a security mechanism because you saw I couldn't click the deny button. But it's actually a problem when you're trying to allow malicious behavior for reverse engineering. Let me exit out of this and let me try using an older emulator version. So I think I'm on Android 11 at the moment. So let me kill my current Android version. Yeah, I'm on RE-Droid Android 11. So let me kill this so we can get the actual behavior of this application without this annoying prevention. I think I have an Android 8. Yes, so I can run Android 8.1.0, and that might allow me to bypass this. So let me run this one again. And that should be spinning up my emulator one more time. So I'm gonna give this a little bit of time to reload. So now I have my older version of my Android emulator up and running. Let me connect my screen one more time. So here we go, throwback, older version of Android. And let me just reinstall my application. So it was in samples, it was Banker. Looks good. Let's see if it installed properly. Here we go, that shows the full name. And let me connect. Oh no, I need to do root one more time. So let me, one more time, gotta remember to do root. Because if you don't, there's a lot more limitations that you have, like if you want to send broadcasts or anything, which I'll probably do in a little bit, then it doesn't actually let you unless you're running as root. So I just kind of by default like to do that. Let me do adb shell, get back to my directory. There's my package and my code cache. So I think we're ready to run again. Let me see if this will work. So fingers crossed that this actually has less security mechanisms. All right, we're running our malware. I'm gonna try and enable my accessibility. And it's showing me at the center of the screen, so maybe that's gonna work this time. It's allowing to observe actions, retrieve window content. I think this is gonna work. Sweet, that worked. So yay, Android 8 does not have that protection mechanism, so that's nice for me. Whoa. Okay, it's doing stuff, and I'm definitely gonna allow this because I'm trying to trigger as much behavior as possible to see what's gonna happen. Yeah, let's see what it's doing. I think it's doing something fishy back there. It's doing a few different things. Let's see what happened. Looks like we have a lot of different stuff inside of here. And what I like to do is I like to do AL for all and then list, because a lot of times I've seen malware authors name something like dot something or other, and if it's named dot something, it's actually hidden if you just do ls, so you won't be able to see it. So kind of by default, I'll like to do this, just to make sure there's not anything inside of there. So let me see what's inside of this app APK. That looks kind of promising. Whoops. Yeah. Can I type though is the question. No, there's nothing in here. So we have a couple different things. This looks kind of interesting. Let's see what's in there. I'm not sure. I'm gonna maybe pull this from the device and take a closer look and just kind of peruse these files. There might not, oops, I exited out of my application, didn't I? Let's see what's in this shared preps. This is looking kind of interesting. Some XML files, maybe some settings for this malware. We did have, when I was reviewing the code, it was editing the shared preferences. So that's kind of like a config that it uses for different runtime values. So if it's editing the shared preferences and it is going to a different component in the application, it's kind of a convenient way for the malware to share different data that's specific to the particular device that it's currently infecting. So maybe this is related to that, I'm guessing. But let me just pull maybe this whole directory and we'll take a closer look and see what files are inside of here. I'm gonna exit out of here. So I'm gonna do AB, pull. I'm just gonna take this whole directory because I'm feeling lazy. And then let's put it in, you know what, I'm gonna do thinker output. And we'll pull this into there. So it pulled all of the files. So that should be our full package and any of the files that this application potentially dropped to disk while it was executing. And let me see, nothing else is really happening, but you know, before I do that, I might pull this one more time because let me take a look at the code. There were a few things, services and receivers, that I kind of just want to try broadcasting across the application to see if they potentially trigger our APK getting written to disk or anything else interesting. So these intent filters will actually trigger this class if the system broadcasts any of these different actions. So maybe, if I remember, this broadcast receiver class was actually the class that was triggering our file to get written to disk. That was potentially our additional APK. So let me just mess around with that and see if any of these trigger something. Looks like we're also looking for WhatsApp push delivery and an SMS message. So let me just kind of play around with a few of these and see what happens. I think I'm going to pick on this one first. Let's try boot completed. So I'm going to go back to my terminal. Maybe we'll pull this directory one more time after we do all of this just to see if we got anything additional. So I'm going to do Android Manager broadcast to send a broadcast across the whole device. So this is actually going to get sent out to every single application on the device, not just this app, but I'm specifically trying to target this app to get any potential behavior. So this is going to be my action. So that action is actually broadcast across the whole device. Doesn't really look like anything interesting happened, but if we go to our directory, .b. Let's see if it dropped anything inside of our APK folder. It doesn't look like it, so maybe this is a fruitless effort, but it's worth a shot. Let me try SMS deliver, see if anything happens. This might actually crash it because this SMS deliver requires extra kind of parameters as extra values. So if I don't pass any parameters, which I'm not going to because I'm being lazy right now, it might actually crash the application if it's trying to access these. But let's just wing it and see. That looks fine. I don't think anything happened. Nope, looks like that didn't do anything. Let me go through and pick on something else. So here's another class. I'm going to pick on maybe this device admin one. That shouldn't break anything, but it might trigger. What's in this class? Nothing? That's interesting. Okay, nothing happens if that's the case, but let me try anyway, just because. Now did anything happen? I think that's a big fat no. Nope. I don't think anything happened, but you know what? I'm still gonna pull this new one anyway. So I'm deleting our old directory that we pulled. I'm gonna go back up and I'm gonna pull the new one just in case all of these efforts happen to trigger something that we didn't notice. So now I actually have the new directory, and I'm actually gonna put that on my host machine so I can just maybe drop these into Notepad++ or something and take a closer look at them. All right, so I've pulled all of the contents of the folder of our application that we pulled from our actual Android emulator. And now we can just kind of take a look around these different directories to see if there's anything of interest inside of here. So this was pulled after we did all of our different broadcast triggering that was trying to trigger any different malicious behavior in the device. So we already checked this one. There was nothing inside of this app APK. Let me see, app textures. Nope, nothing. Okay, there is something inside of this app web view. And let me see, what's in here? Interesting. Okay, so here's maybe some blob storage that it's trying to see inside of Azure. Oh, this is very interesting. And a log, I like that. Maybe this is potentially a log of the device actions. Let me just see what's all inside of here. That looks like a database with some stuff inside of it. Manifest for the database. Yeah, so it's trying to create a database that it might be able to query from inside of this app web view folder, which is where we currently are. Default local storage. Maybe it's trying to store different actions that the user for the device is taking, or passwords or something, and put that in a database. So that's some really interesting functionality that we've actually found here. Session storage. This looks like another one. Ooh, and this log file actually has something inside of it. And it looks like it is encoded, which is too bad. Or maybe it's in the form of a database and we'd actually need to query it. Let me see, I don't think there's anything else. Yeah, so this is just creating a couple different databases. And it's maybe doing a remote session. Yeah, very interesting stuff that we have stumbled upon. Let me get rid of all of this. Alright, we didn't find our APK, but we did find some interesting stuff. I think we looked at all of these, if I remember. Web data. Ooh, okay. I'm guessing this is going to record anything I do on the web. Okay, and it's in the form of a SQL database. But it is definitely storing a ton of different stuff about, let's see, it's creating a table for autofill profile emails. Basically, I think this is just taking a bunch of different information, like potentially your credit card data or street name, address data, maybe related to, yeah, looks like it's trying to store data related to your credit cards and your banking information, which does make sense since this is a banking Trojan. So that's kind of nice, or nasty. Yeah, this is all just related to the SQL database that it's using, that it's probably going to be writing to every time you open up a banking application or anything that it's specifically targeting. So cool, we found a lot of functionality here. That was actually a really successful effort. Looks like there's nothing in here. Let me see these files. See if there's anything interesting. No, no. No. I don't know. User experience metrics. Is the malware actually worried about the user experience of the malware? I seriously doubt it. This is probably just some configuration for the app. Not sure, it doesn't seem really interesting. I think the main thing that we stumbled upon was the actual SQL database storing all of the different banking related stuff. Let me just see if there's anything interesting inside of here. This looks just like normal Android stuff that's writing to the cache and everything. Oh, we did have this shared prefs folder, I forgot. Let me take a look at what's in here. Last version code used. Yeah, that's not interesting. Ooh. I like this. Ooh, this is really interesting. So let's see. Looks like this might actually... Oh yeah, so this, if we remember, we had our shared preferences. Let me pull that up inside of our code. See if we can find something. Navigation, text search, shared preferences. So it was doing all of this stuff where it was writing to these shared preferences. Like we have this ID bot. Let me see if we have ID bot in Notepad++. Let's see if we have ID. No. ID settings may be related to that. Let's see if we have the word bot. There we go, ID bot. So this looks like the actual runtime settings for the particular device that it was infecting, which is my device in this case. We have our package name. So I'm guessing that these shared preferences inside of this XML is going to be the ones that are being set for all of this that are alive within the context of the application. So I think we've got a really good find here. We can see potentially all of the different behavior of this sample. So kill application, looks like it's got a keylogger. I don't know, maybe it's tracking the time you're looking at your emails. I don't know. SMS, hidden SMS, looks like it's able to lock the device. Let me see if there's anything else interesting. Start a service. Something to do with your banks, maybe the statistics of your banks. Looks like there's some injection opportunity. And we do have a key. I wonder what that key is for. Log SMS. I don't think... Not sure exactly what this is recording. Looks just weird. Maybe this is because I was doing a bunch of different services and sending those out, not sure. But anyway, yeah, I think we found a lot of functionality for this application. Even though we did not actually find our APK that is dropped, we did find the settings for it, and we did see a lot of the different behavior of the application. So I think I'm gonna call it from here for dynamic behavior, and I think in the next video we'll jump back into the code and see if there's anything else of interest that we can find there, and maybe check some of those different services or receivers that were actually listening for some of those intents that we were trying to broadcast across the device. So thanks so much for watching Lori Wired, everyone. In this video, we continued our analysis of our Android banking Trojan, and we actually found a lot of interesting stuff from actually just running the application dynamically inside of an ARM-based emulator. So we found the shared preferences that was in an XML format. We also found that it was actually creating a SQL database where it was potentially storing a ton of different banking-related data and stuff that it might find while it's spying on the device. So in the next video, we'll go ahead and jump back into the code and see what we can find from there. So thanks so much for watching Lori Wired, everyone, and I'll catch you in the next video.